You will also have to be able to do this procedure with functions involving logarithms. And before that, let's sketch the log and figure out what it looks like. And if you notice, I will color code in these reviews, so if I write something in red, you need to memorize it. So this is the graph of natural log x. It has a point here of 1, 0. So log of 1 is 0. If you want to put another point on here, I guess if you call this e, natural log of e would be 1. So again, start with the domain. So what this graph tells me is that the domain of the logarithm function is when the inside is positive. So here we don't see any function to the left of the y-axis. So the domain of a log is all values of x that make the inside of the log positive. So the domain of f will be all x that make the inside strictly positive. You can't have the log of 0, you can't have the log of a negative. And that's just x is greater than negative 1. So our domain is negative 1 to infinity. Now we can find where it's 0, positive, and negative, so we need to start factoring this. So the first thing I see is a common factor of log of x plus 1, so we can factor it out. Okay. If we take the log out of the first term, we'll be left with an x squared. If we take the log out of the second term, we'll be left with a negative x. And if we take the log out of the third term, a minus 12. And we care where this is 0. Factor the quadratic. And set it to 0. All right, we're now going to set each factor to 0 and solve. So the first factor. All right. So when does the logarithm equal to 0? Well, according to this, look at the graph, it looks to me like the logarithm will return 0 when the inside of it is positive 1. So this will be 0 when the inside of the log is equal to positive 1, and we see that that is when x is 0. Set the next two factors to 0, and the last be careful. Make sure you check that your roots are actually in the domain, are the solutions you got from the math. X equals negative 3. It is outside of the domain, so it is not a root. So make sure you check that the solutions you get from the math are actually in the domain. So this is not in the domain. So not root. Which means the only two roots of this function are 0 and 4. Drawing a number line, remember we have a domain restriction of negative 1. We cannot go beyond this. And our function is, we have roots at 0 and 4. All right. Pick something between negative 1 and 0. I'm going to choose negative 1/2. If we plug negative 1/2 into this, into this x, we're going to get log of positive 1/2. I don't know what log of a half is, but from the graph, here's 0, here's 1. We see log of a half, it's some negative value. So this first factor would be negative. If x is negative 1/2, we would get negative 1/2 minus 4, that's negative. Negative 1/2 plus 3 is positive. So we have the product of two negatives and a positive. That produces something positive. Between 0 and 4 lives 1, so plug 1 in. If we plug 1 into this logarithm, we're going to get natural log of 2. And according to the graph, natural log of 2 is some positive value. If x is 1, 1 minus 4 is negative, and 1 plus 3 is positive, so we have two positives and a negative. That multiplies to be negative. So our function is less than 0. Choose x to be 5. If x is 5, we get natural log of 6 here. Natural log of 6, it's some positive number. If x is 5, 5 minus 4 is positive, 5 plus 3 is positive, and the product of three positive numbers is definitely positive. Write your answer in interval notation. So f is greater than 0 from negative 1 to 0, union 4 to infinity, and f is less than 0 from 0 to 4.